So we're looking at balancing chemical equations. One of the things that people remember most about chemistry class, if they're doing a lot of stuff in the book, this is one of the things you remember from the book the most. So, a couple of terms. So there's going to be coefficients and subscripts, and I need you to be sure to do the right thing with each. For the coefficient, this indicates how many of each substance is present. The default is 1. I'm going to underline where you're going to put coefficients. So I have an example equation up here. And in front of these substances, you might have a number like 5 or 6, whatever. You put numbers there. That's the position. That's the position for the coefficient. And if you don't write anything, you count it as 1. So as it's written right now, there's 1 hydrogen and 1 oxygen molecule and 1 water molecule. Subscript. Subscript. This indicates how many of a particular atom or polyatomic ion is present, and the default is 1. The subscript is written here. There are 2 hydrogen atoms in this molecule. There are 2 oxygen atoms in this molecule. And over here we got 2. We see nothing written here. That's subscript. It would be 1. That's the default. There's 1 oxygen atom. So when you are balancing equations, I wrote down 2 things that are really important, and then a couple of terms. You are going to add coefficients. And by add, I just mean you're going to write coefficients. We should get rid of this add, and we'll just say you're going to write, right? You can change that. So if you write an incorrect coefficient, you can erase it and put another one, as long as you make your equation balanced. So my point here, you can change these. You do not change subscripts. I can write whatever number I want here to have more and more and more of these hydrogen molecules, but if I change this number, I'm changing what substance I'm talking about. Right? If I change H2O, if I just start writing numbers here, I might be talking about a different substance. I'm talking about a different reaction. All we're looking for here is a ratio of hydrogen and oxygen molecules that would give us water molecules where matter is conserved, where we have the same number of atoms on the reactant and product sides. So that's number 2. You have to have the same number of each type of atom on both sides of the arrow. Just a couple notes. Substances to the left of the arrow are called reactants. So we'd look at this equation and we'd say, oh, H2 and O2, those are the reactants for this reaction. And if you have substances on the right, when you have substances on the right side of the arrow, we call these products. So we have 2 reactants and we have 1 product. Okay. Now we're going to balance it. So we look at this reaction and we can take an atom inventory. This is a pretty simple reaction, and I think once you get the hang of this, you're probably not going to need atom inventories for a reaction like this, but it's good for us to take stock and make sure we know exactly how many of each atom we have. So we look, we say, oh, there's 2 hydrogen atoms right now. Right? I'm not writing anything yet. I don't know if it's balanced, right? You might look at some equations, chemical equations, and you might say, oh, it's already balanced, and then you just leave everything how it is. So first I want to check, is it balanced? So I'm writing this 2 on the left side, and notice here. If I'm doing an atom inventory, I'm paying attention to that arrow. That arrow is the dividing line between reactants and products, and I need to make sure the number of atoms over here equals the number of atoms over here. Look at oxygen, we got 2. Now if I look at water, we've got 2 hydrogens and 1 oxygen. Okay, so we see that it's not a balanced equation, and we can quickly see what we're going to need to do to make this balanced. I'm going to go ahead and add a 2 here. Right? I'm going to write a coefficient of 2 in front of the water. When I do that, I'm going to have 2 water molecules, so I'm going to have 2 times 2, or 4 hydrogen atoms, and I'm going to have 2 times 1, or 2 oxygen atoms. So you can keep track like this, and and make sure that everything's balanced. Now, if I see it, if I look, my oxygens are both 2, but my hydrogens are not balanced anymore. I've got 4 on the product side and only 2 on the reactant side. So I need to write 2 here, and that'll give me 4. So that's a balanced equation. You don't need to write the 1 here, although if you're practicing in the beginning and you just want to make sure that you do it, that's fine. It's usually not written, but just as a placeholder, it's not so bad. So that's balancing hydrogen and oxygen turning into water. This could be in a fire. All right, let's look at a harder one. So we have 2 reactants, and we have 2 products. I tend to write those lines underneath there to remind me I got to pay attention to coefficients. All right, so if I'm going to take an atom, and again, you might look at these reactions and or equations, and you can kind of balance them without doing an atom inventory every time. That's fine, but I'm going to keep track of it right now. Aluminum, chlorine. Okay, so we've got aluminum and chlorine, that's Al and Cl3. Sodium carbonate react, and we get sodium chloride and aluminum carbonate. So aluminum on the reactant side, there's no subscript. So right now there is 1. Chlorine on the reactant side is right now 3. Sodium is 2. Carbon is 1. Oxygen is 3. Go down the other side, we got sodium is 1. Chlorine is 1, aluminum 2, carbon's in the parentheses, the 3 gets distributed, so 1 carbon in the parentheses, but there's 3 of them, got that, and then we got oxygen, we got 9 oxygens. So there are some ways that are going to be faster than others. For right now, I'm just gonna go ahead and start at the top. Okay, so I've got aluminum here, and there's 1 aluminum on the reactant side, 2 aluminum on the product side. So I'm just going to go ahead and double it. All right, so now I have 2 aluminums, and I have 6 chlorines. All right, well, we can go ahead and take care of chlorine now. Chlorine is on there's no coefficient there. So we got 1, so I'm just going to go ahead and write a 6. And now I'm going to have 6 chlorines. So now my aluminum and chlorines are balanced. That 6 also changes the number of sodium atoms. So sodium should now be 6 on the product side. And then I can look on the reactant side, I only have 2, so I'm going to need to multiply that by 3. So now I've got 6 sodium atoms. Multiply 3 times 1. 3 carbon atoms, it happened to balance the carbon. Sometimes you might start with the wrong, start with an atom that doesn't make things this easy. And then we got 3 times 3 oxygens, or 9. So that's now balanced. So we have coefficients of 2, 3, 6, and 1. Although I didn't write the 1, you can. All right, practice.